Okay, a little bit on transcription. We didn't walk through this in class, so I'm going to spend a minute or two talking about transcribing things. This is important because since I am up here talking rather than writing everything down, sometimes you need to be able to hear the words and know what chemical I am talking about. And it's easier if you can do all of the chemical equation rather than just like, oh, sodium, that's Na. So you had the homework assignment where you're transcribing things. When we do the types of reactions, then we will have some of the transcriptions that are specifically for those types of reactions. But I wanted to go through a few examples that we want to pay attention to. The one thing you want to pay attention to is phase, because that can make a difference in what's going on in the chemical reaction. There are some chemical reactions that the story completely changes when we have something aqueous versus solid. And I'm working on that with some of my upperclassmen right now, that like we include them in the equation if they're aqueous, but not if they're solid. So it's really important that if that's identified, that you include that when you're writing down the equation. Sometimes it's not included, but sometimes it is. You want to see if the question asks you to balance. And probably the biggest mistake that I see is with ionic compounds. We don't write the charges in the ionic compounds because they're supposed to be neutralized, but you have to make sure the cations and the anions, remember the cations are positive, the anions are negative. You have to make sure all of those positives and negatives cancel each other out. And then there are some simple covalent compounds you should know. So if it says oxygen, I'm going to write O2 because I know oxygen is diatomic, unless it specifically says monoatomic. So if it says monoatomic, mono means one, I would just write one. But if it just says oxygen, I'm just going to assume that's O2, right? But you should know if it says water, you should know that one. This one is on your polyatomic ion sheet. That one's ammonia. Okay, it's very similar to an ion, which has 4 hydrogens. That's ammonium, but this one's ammonia. And then this one gets used quite a bit, and that's methane. All right, so let's try a couple of examples. Okay, so I might describe a reaction as methane gas combusts in the presence of gaseous oxygen to form gaseous carbon dioxide and water. So there's some things that, some words that you should just translate to symbols in your mind. So when you see and, that's going to be a plus. That means these two things are on the same side of the equation. Anything that indicates a reaction, combusts, yields, neutralizes, those things are our arrow. Now this one's a little bit tricky because I say it combusts in the presence of. So methane is in the presence of oxygen. That comes before the arrow. So what symbol am I going to use for methane? CH4. And then that's a gas. And it is in the presence of oxygen, but oxygen's one of my diatomics, so I put O2. And so this is the combusts part, that's the reaction to form carbon dioxide. Now this isn't one that I said you had to memorize, but we should be able to get some of these just from their names. So without a prefix, that just means it's one carbon, and then dioxide means there's 3 of them. And water. And then if the question says transcribe and balance, then I would need to go back through and say, okay, I have 4 hydrogens here, so I need a 2 here. That gives me 2 plus 2 is 4 oxygens, so I need a 2 here.
Is water supposed to be a gas too?
So it says gaseous carbon dioxide and water, so unless it indicates that water is liquid, we assume the gaseous applies to both. And in fact, there's so much heat in a fire that you're not going to get droplets of water. It's going to be in the air. So this one involves a couple of different things. We've got some ionic things we need to be aware of, but sometimes a reaction is going to give you like the main event of what is produced and not tell you the rest of the products, and you're supposed to kind of figure those out. So let's see what's going on here. We have calcium chloride, and so we might want to write CaCl, but we have to remember it has to be charge balanced, right? So calcium has what charge? +2, and chlorine is -1. So how many chlorines do I need? 2. So this is CaCl2, and it says it's aqueous. And then I have silver chloride. So silver was one of those weird ones in the transition metals that it's pretty much always the same charge, and so we don't always write the Roman numeral for it. So it's always a +1, and so we can just put one of those. And it is with nitrate. What is nitrate? It's got Ni, so that's going to be nitrogen. And 8 means there's at least one oxygen, right? How many oxygens do I have? 3. Okay. And so this is where, if you're going through this in your homework and you don't remember, go ahead, look it up. Don't stand there being frustrated. Go ahead and look it up, but make a note that like I had to look that up. So if I keep having to look it up, that needs to go on my note card so I remember that. Okay, this one is -1, this one is +1, so they cancel each other out. That one was also aqueous. And so since this says with, that's my plus sign. And then it says to form, that's my arrow. And then it says solid silver chloride. So silver chloride is going to be AgCl. Do I need to change the numbers of them? No, because silver was +1 and chlorine was +1. Okay, and then this is a solid. Now that's where it ends, but we also know conservation of matter, things don't just disappear. So that means the other things are still in solution. They're still around. They're what we call spectator ions. So they didn't react, they didn't do anything special, they're just kind of floating in the water. So what other ions are still floating around somewhere? Calcium. And what else? Nitrate. Okay, so these two ions were aqueous at the beginning. We mixed the two things together. They're still aqueous, so they're kind of like spectators at a sporting event. They're not on the field participating in the chemical reaction. They're just hanging out watching the silver and the chlorine get together. All right, and then if we needed to balance this, that's when we start paying attention to how many chlorines there are. Okay, so we don't just move this 2 over to the silver chloride because that doesn't need 2 chlorines. But we are going to say we need 2 of these because we have 2 chlorines here now and 2 here. So that means I need 2 silver nitrates, and that means I need 2 nitrates. Okay, so balancing should be the last thing you do. When you're doing ionic compounds, before you start or before you move on from a chemical, before you move on from a compound, make sure that within that chemical, the positive charges balance the negative